In this video, we are going to look at electron configurations. Now, electrons are constantly moving and they are in the empty space around the nucleus. Now, the shape of the electron path or where the electron exists is the orbital. Electrons exist in orbitals. In this class, we're really only going to cover two orbitals, but there are a total of four. The sphere-shaped orbitals are called the s orbitals, and the figure-8 or dumbbell-shaped orbitals are called the p orbitals. With the s orbitals, there is only one suborbital. And two electrons can fit into each suborbital. So we have a maximum of two electrons in each s orbital. And the orbital does have a sphere shape. The p orbital has three suborbitals. And since we can fit two electrons in each orbital, that means we can have a maximum of six electrons in the p orbital. The p orbital is going to have a figure-8 shape or a dumbbell shape, and it will exist in the x direction, the y direction, and the z. So this might be the py, px, and pz orbitals, where the lobes of the pz orbital are coming out at you and back into the page. Now, the distance between the electrons and the nucleus is called the energy level. And there are infinite, that looks like a p orbital. We'll just write out infinite. There are infinite number of energy levels. The closest energy level to the nucleus is called the n equals 1 energy level, and they increase as you go up. So we'll get the n equals 1, n equals 2, n equals 3, etc. Now, electrons are free to move between energy levels. It's just kind of like going up and down floors in a building. If you're moving up, if an electron is moving up an energy level, it's going to require energy. So the atom is going to absorb energy. If you're moving down, if the electron is moving down, it will release energy. In the n equals 1 energy level, there is one s orbital. In the n equals 2 energy level, there is one s and one p orbital. So what that means is in the n equals 1 energy level, we can have only two electrons. In the n equals 2 energy level, we can have a total of 8 electrons, one s orbital with 2 electrons and one p orbital with 6 electrons gives us a total of 8 electrons. When you're looking at the periodic table, going across the table, you can find your energy levels. So up here at the top, we're going to have n equals 1. This is the first period. Remember, going across the periodic table, these are periods. Going down the periodic table, we have our groups. So we have the n equals 1, n equals 2, and n equals 3 energy levels. In the n equals 1, I can fit 2 electrons. N equals 2, I can fit 8. And if you look at the electrons, I'm going to fit 1 electron here, 2 here, and then we can go 3, 4, 5, 6, 7, 8, 9, 10. So I can talk about these electrons and say where they're going to hang out. This block right here is called the S block. So the last filled electrons for elements in this block are going to be in the s orbital. Over on the other side of the periodic table over here, we have what is called the p block. So elements within the p block, the last filled orbitals, are going to be in the p orbital. Notice I did not include helium in the p block. Helium is actually included in the s block. Helium is in the first energy level, so it cannot have any p electrons. So when we are filling in our energy level or our electrons into the energy levels, we can use the periodic table to fill in our electrons. So let's look at some examples. Give the ground state electron configuration for the following elements. The first one we have is fluorine. So I'm going to go back to my periodic table and I'm going to find fluorine. Fluorine is right here. I also noticed that fluorine has 9 protons, so that means I have 9 electrons. I am going to fill in those electrons by using the periodic table. So n equals 1, I can only have 2 electrons. So when I fill that in, I'm going to write it as n equals 1. So the energy level is 1. My orbital is s. It's in the s block, and I have 2 electrons. Notice the electrons are written as a superscript. Now, this represents only 2 electrons, and I need a total of 9. So if I look at my periodic table, I've filled 2 electrons going this way. Now I'm going to come down to my n equals 2 energy level, and I'm going to fill all of my s electrons in, and then I'm going to jump over to my p and fill them all the way over to fluorine. But notice 1, 2, 3, 4, 5. I can only fill 5 electrons in. So for fluorine, I'm going to do 2s2 and then 2p5. When you are finished with your electron configuration, showing where the electrons are hanging out, you should have a total number of electrons that is equal to the number of electrons in your element. So fluorine has 9 electrons. I have 2 plus 2 is 4, plus another 5 is 9. So the number of electrons in my atom is equal to, or element is equal to the number of electrons in my electron configuration. All right, let's look at argon. Now, argon is in period 3, and it is at the last atom in the p block. So I'm going to fill all the way through the p block. And I noticed that argon has 18 electrons. So I'm going to start at 1, 1s2, 2s2, 2p6. Notice that only has 10 electrons, so I've only gone to neon that has 10 electrons. So now I'm going to go to my third energy level, and I'm going to do the exact same thing. 3s2, 3p6. Argon was all the way at the end of the p block, so I have to fill in all 6 electrons. When you count up your total electrons, we have 2, 4, 6 plus 12 is 18. So I have a total of 18 electrons, which is good because argon has 18 electrons. Now with calcium, we have it in the s block. So the last filled electrons are going to be s electrons, and I'm in the fourth energy level. So I need to go all the way through the s block. So my last filled electron should be 4s2. So I'm going to start at the very beginning. We have 1s2, 2s2, 2p6, 3s2, 3p6. Now that took me all the way to argon. But in order to get to calcium, which has 20 electrons, I need to add two more. So I'm going to put them in the 4s2 energy level. As you can see, writing these out can take a while. So we can use what is called the noble gas electron configuration of the elements. And when you're using the noble gas electron configuration, you're going to substitute some of the electrons with the closest noble gas. So for fluorine, my closest noble gas can't be neon because it has more electrons. I have to get the closest noble gas that has less electrons. So in this case, it has to be helium. So I am going to substitute all of the electrons that represent helium, and I don't have to write them in. I can just write the electrons after that. And when I substitute helium in, I need to write helium in brackets, and then I can put all of the other electrons in there. So this is the noble gas configuration of fluorine. And you might be thinking to yourself, that didn't actually save that much time because all we did was replace the 1s2. And you are correct. But let's look at argon. Well, argon is a noble gas. So I can just write argon in my brackets. That is a lot faster than writing out my full electron configuration. Now, we already saw how calcium, we did all of argon, but then we just added our 4s2. So this is a much faster way of showing our electron configurations.